So yeah, as far as the midterm goes, we'll just come to class, you'll take it on the big computers, and it'll be right here, right? In the midterm module at the bottom there. You'll take it, and remember that you get access to like the documentation pages, you get all those nice things. So, and you also get like a little temporary Jupyter notebook, so that's even better. So yeah, today we're just going to review, and feel free to derail me at any point, but I'll try to go over as many things as I could think of. I came up with some silly little examples, and that'll be that. I need to open up Jupyter real quick, and I'll make a new file for just today. And so we still have a chapter to finish. We're still like in the middle of a chapter, but we'll deal with that after the midterm next week. It's a bad time for Jupyter to not work. There it goes. So here, I'll make a new file for today, and it will be, I'll call it midterm review. There. So yeah, let's get that going. And yeah, pretty much what I want to do is like, let's practice first, just doing random stuff with tables, moving around, and go from there. So we're gonna go to this documentation pages. I prefer, you'll get both of these as you do the test, but I prefer this one for some reason. It makes more sense to me, but you can get used to whichever one you like, or flip around between the two, because there are some slight differences. But I just want to remember or remind you how to do some table steps. Like, let's make an empty table, let's fill it in, let's read from files, right? Add some columns, it'll all work out. So yeah, just mostly me typing stuff today. So let me make a brand new table. So table by itself just makes a blank table, you see nothing, but you can add columns, right? With some columns, and here are my columns. Let's do some, my example is animals. So do an array. So we got name, you got species, and you've got age. Boop. So let's see here. I would like to, yeah. So here, we're gonna have a cat, we're gonna have a tiger, and we're gonna have a bulldog. Those are my example animals, and their names will be, let's do my cat, his name is not my name, his name is Alonzo, and the tiger that I know is from Frosted Flakes, you have Tony the Tiger, and the bulldog is the mascot of Fresno State. We've got Victor E. Victor E. Bulldog is his name, and yeah, the ages of all of them, my cat is 5, Tony the Tiger apparently was introduced in 1952 at the start of whenever they came out with Frosted Flakes. So whatever 2026 minus 1952 is his age. You can let Python do the work. And I have no clue how old Victory Bulldog is, but let's assume he's a bit older. They do replace him every so often. So that's a table. That's a table with some stuff. You got a bunch of columns, you got a bunch of rows, right? And you can give this a name. Call it T. So there they all are. You can ask how many columns, how many rows there are. So rows are the things that go horizontally. So T, you can ask num rows, right? That's like a variable that lives within the table itself, and it's here on the documentation page. So rows are the different pieces of data. So there's like 3 animals, so there's 3 rows, right? And then columns are the different kinds of data. So you got the name column, you got the species column, and you got the age column. So there's 3 of those as well. So t.num columns. You can also get the labels of all the columns. It's called t.labels. If you ever need that, that'll give it back to you in like, it's an array-like thing, but it gives parentheses. So that's how you can get all those names real quick. And yeah, so I guess the first thing that you can do to a table is kind of shrink it down and pick out what you like. That's something that we talked about first. You can say table's name dot select, right? Table's name, select the things you want out of it. So select the columns. You can also reorder the columns in this way. You can give the name of the column, or you can give the index of the column. Remember, the indices start at 0. So like the name column would be index 0. So I can say t.select just give me the name stuff. So it gives me back a new table of only the name things. And then maybe I want age as well, so I could say name age, and it'll just give me those two as a new table. It's not updating the T table, it's just giving me back a brand new table, just like that. And the age column, by the way, is column number 0, 1, 2. And so I could also ask for it this way. I could say name, comma, 2. I'd still get the age. All right, so just shout out if you have any questions about this stuff. I'm just going to go over this. And yeah, the second you select something, it gives you back a new table. And so the original table T has not been changed. It still has those 3 columns, all that same data. There's no difference. Okay. The flip side of selecting is dropping. You can say, instead of what columns you want, you can say what columns you don't. Or you can say which columns you don't want, and it will give you the table back without those things. So you say t.drop, like maybe I just want the name of the species, so let's drop the age. Slightly shorter to type that, right? And that gives you back that new table. And again, it does not change the table. It does not change the table at all. Sometimes you don't like, or you read in a data file and like the column names are very long and weird, you might want to change them. So the way that you do that is you do t.relabeled, it's past tense, relabeled, and then you say what you want to relabel. So maybe I want to take my T table and I want to, I don't know, turn it into Spanish. So relabeled the name column, you say what you want to rename, and then you give it its new name, like nombre. And so then you've got that going on. So the name column has been changed, and again, it hasn't messed with the table. You do have to be careful with this documentation page, because one of these guys, this one talks about one called relabel, and that one does mess with the table. I'm not teaching you that one. I think it's a little, I prefer the table operations that give you back a new table. That's better, but do keep that in mind. This documentation page says relabeled. It does not show you the relabel one. So I guess I prefer this one for that idea, but you get it. All right, so relabel gives you back a new table, and that's how that works. We also learned about like the pieces of the data structures, I guess, if you've heard that word, that make up all of the columns of our table. Every column is an array of data items, right? Everything is an array. An array is just a list of data. It's a sequence of data, and you can make your own sequences. You can use the make array function to make an array of stuff. You can also use some of our NumPy operations, our NumPy functions, to build up sequences or arrays in some way that you care about. And one of the most important ones was np.arange. So that gives you back an array that holds a range of values. That's kind of why it's called that. And there's 3 different ways that you can call it. You can call it with just a stopping point, call it with a starting and a stopping point, or call it with starting point, stopping point, and how much to increment by, or decrement by if it's going negative. So yeah, by default, or just remember that the stopping point, whatever you give it, it's going to go up to but not including that value. So that's always important to remember. It's up to, but not including. It does always start at the starting value. By default, if you don't give a starting value, it's 0. Okay? So, yeah, for example, if I want to count from 1 to 100 by 5s, I say np.arange start, or let's do 0 to 100 by 5. So start at 0, go to 100, and I'm not going to type 100 here. I want to type something bigger, because it will go, if I just say, and go by 5s, it will stop at 100, and it won't include it by default. All right, that's up to, but not including. So if I just give a bigger value, I can give 105 if I wanted to, but I just give 101 here. It now will go up to 101, but not include it, and so that 100 is now safely there. Okay, so that's one way to call it. And yeah, once you have an array, you can ask stuff about it. You can always ask for how big it is. There's a bunch of operations that you can do on arrays. It's over here, like get the max value, get the min value, get the sum, absolute value, get the length with len, like how many numbers are from 0 to 100. What's the length of all this? 21, apparently. 21 numbers here. Okay, so yeah, that's what's going on. And you can say, you can go backwards, be np.arange, start at 200, go to 0, and go like count by negative 10s at a time, right? And again, this won't stop at 0 because I put 0 here. It's not good. It's like up to, but not including. And so if I wanted to go all the way down to 0, I would have to say something smaller, but not too small, right? So maybe like -1 is a good value. It'll never get there, but like that'll at least let it stop at 0. Does that make sense? Remembering all that? And yeah, that gives you the ability to just quickly make a range of items and a range of numbers that like follow a pattern, a linear pattern. And that's useful. So when you have that, you can every array you can put into the column of a table, and so that's something that we could do now too. So let's make a table with some columns, and we can have x be all the numbers from, I don't know, 0 to 100, and you can have y be all the numbers from 200 to 0. It's got to be the same amount if you want them to be the same, if you want them to be in the table, so you have to take care that there's also 21 things here. That's also important. So yeah, but this will make a table. I can call this like T2. Remember that if you are given it in a bunch of columns form, you do have to give just as many. So here is my table where like the x values are going to range from 0 to 100 by 5s, and the y values are going to range from 200 to 0 by 10s, counting downward. All right. And so I've got a table now with x and y columns, and I called it T2, and we can graph that, right? So you got any table, you got some numbers, you can visualize stuff with a few different options. The first is scatter, right? Scatter just like throws a dot. You say what the x values are, which column name you're going to use as the x values or index, what column name or index you're going to use as the y values, and there's a secret option there that we haven't talked about yet, but we'll get to it one day. But that just turns everything into a dot, and we just have 2 columns anyway, so you just like pick one to be the x, pick one to be the y. How about use the names that we've given? So t2.scatter, use the x column as the x values, use the y column as the y values, and it'll try to make the best graph that it can. It'll zoom out as much as it can, and yeah, this is what we made. So it graphs 0, 200. There it is. It graphs 5, 190. So it's just like decreasing, and yeah, that's how you can make a table and visualize it too. Any questions about that? Pretty pictures are important. You can get away with the scatter operation by just saying what you want as the x columns, and it's just going to use every numerical thing that it can for the y column. So you just scatter where x is the x-axis. It'll just go and find everybody else, every other column, and graph those 2, potentially with different colors if there's multiple columns, but there's just one here, so that's why we see that. Okay, so yeah, it's just like table operations in a nutshell. Yeah, and so just like go back to this page, go back to all the code that I wrote. It will be a good way to review. And yeah, for my main example of the day, what I picked when I was trying to make these slides was the game Wordle. Hopefully you've played that, especially like during the pandemic. It got really popular, right? But let me just describe the idea of Wordle, just in case you've never played or it's been so long you can't remember. The game is like you get 6 tries to guess a 5-letter word, and as you make guesses, Wordle will tell you, right, if it gives you yellow things on your guess, it means that that letter was part of the secret word of the day. Everybody's trying to guess the same word each day, so if it was yellow, it tells you that letter, like there was an R in the word, but it wasn't in that spot where you guessed. All right, so there's an R somewhere, it's just not the second letter. That's all it's saying. And then eventually when you get it in the right spot, it shows you green, and so you want to guess the word like that. Okay, so that's Wordle, and what I want to do is I would like to pick what is the best guess. What's the best first thing to guess in Wordle to have the most likely chance of getting a bunch of letters for any word that could be there? So that's my goal right now. So what I've done is I've made a data set for us of every single Wordle word. So here, it's in data folder. It's called wordle.csv. So it's every word that could be in Wordle. So table.read table data/wordle.csv. And that's words. So there they all are. And so here's every single word, there's a few thousand that could ever be the secret word of the day for Wordle. I've heard recently that they've started to reuse the words, so I guess we've made it to the end, or they didn't like some of these words or something. But yeah, what our goal for the rest of this example is going to be, let's figure out the best first guess in Wordle that's going to have the most likely chance of getting you a lot of options, like picking at least a lot of the letters, maybe not in the right spot, but that will appear in theory in the word. So my go-to when I play Wordle is the word irate, and that's just because it has a lot of vowels. I've heard that that's a good one, and that works well for me. So maybe you have one too. But yeah, that's the game. And so to get there, we're going to need to do a few things. Like we need to split up. Like we need to all right, we need to go and analyze all of these Wordle words. And we need to count all right, how many S's are there? How many A's and B's and C's are there in all of these words, right? Because our first guess should be kind of proportional to if a lot of these words have S's, and then that means that an S should probably appear in our first guess. Something like that, right? In a proportional way. So I kind of want to go through all of these words and get that kind of data, like how many A's were there, how many B's were there, like what are the most likely characters to appear in a Wordle word, because that'll tell me which guess I need first, right? And so the way that you can go through these characters is with a for loop. Let me remind you of a for loop. So remember the for loop, you say for, give some variable name, and then you say in, and then you give something that you can go through, which is an array for us in this class, like np.a range. Let's say 1 to 11, which is going to make the numbers from 1 to 10. And what the for loop's going to do is it's going to let this I variable become all the values in that sequence. So I is going to range from 1 to 10, and it'll run the body of this, called the body, this indented bit. And it will run this code on each new value of I, and I is going to change in this way, which means that it's just going to, the first time I will be 1, it prints 1. The second time I will be 2, that's the next element in the sequence. It will print 2. And so you kind of see how this code is going to print from 1 to 10. That makes sense? Because we're going to need that to go through all the Wordle words. You can it just so happens that every string, which is your text in Python land, every string of text is something that you could go through in a for loop, which is not really something I'm going to test you on, but we're going to need it for this example. So I'd be like, for every character C in the string hello, I can do the same thing, print C. Kind of interesting. It's going to let hello be a sequence, to Python, a string, a text string is just a sequence of characters, and you can go through each one individually. Like C gets a chance at being the H first, then the E, all those things. That's what's going to happen, okay? So that's exactly what we're going to see, and that's kind of what we want, all right? That's kind of what we want to have happening. And that will allow us to go through every character and then maybe keep a count of how many characters we've seen. That's our goal. So yeah, I think that is most of what I wanted to say. So I want to do that. Honestly, probably the easier way to keep the count would just be to split up all these words into their individual characters, and I can do that with this loop, right? And maybe I can just make an array of every single Wordle word's characters. That could work for me. So, because then I could just make a giant array. It's here's my goal. Here's an idea. You could totally do this differently, but this is a good example. So here's a blank array that I've called array, and then I can go through every character of a string, like hello, for example, and instead of printing it, I could take that character and be like np.append to the array, that character C, and set that into the array called array. And then what does array hold after I've done that? Do you see how it's split it out into all of its individual characters? And if I do this game, right, of going through every character and every word of the Wordle list, I will have an array of every single character that ever appeared in a Wordle word, split by single characters at that point. That makes sense? Because if I did that, then I could count all of the A's, because I'd have them all separate. I can count all the B's, I'd have them all separate. So that's kind of what I want, and so I wanted to kind of do this process for every word in the Wordle list, and that this is kind of something that I'm going to repeat. So it would be a good idea to turn this into a function, right? So that's a good example of a function. That's why I'm doing it this way. So let's make a function called string or stir to array. All right, so you give me some string s, some stir s, and then here's what I want to do to it. I want to turn it into array, and I'll return that back. So for every character in that string s, it's not hello anymore, put that into the blank array and then return it back. And this will turn every string into an array. All right, say stir to array, like ABC. And that will work for any word that I want to give it. It'll give back to me an array of every individual character out of that string. Does this function make sense? Are there any questions about it? Because we're going to need that. We're going to use it for all those 2,000-ish words in the Wordle list. And yeah, the second you have this, you just kind of call it. Right? We'll call it on every word. Call it on hello, call it on world, because every time you call it, it gives you those string, that string split up into characters. And we've never used it this way before, but np.append, in addition to adding a single thing to an array, it can also combine two big arrays, because you know that what this is going to do, right? It's going to make the array of all the characters in hello, and let's change this to something else. This is world, and this one is going to make all the array of all the characters in world. And so to have two arrays of multiple things in them, np.append is fine with that, and it will just bring them together, even if they both have a bunch of things. So that will build this array. And do you see where I'm going with that? Like this process then for every Wordle world, if I keep on appending this result of this function call to each word, I will eventually end up with an array that's very long of each individual character in every Wordle word. Wordle word is a hard phrase to say. So that's what I want. That's what I'd like to do. And so I kind of want to apply this function, right? That's the key word. I want to apply this string to array function to every character, or sorry, to every word in the Wordle list. And so it's my words table that has all the words, and it's the words column of the words table, words.column, words. That is the array of every single Wordle word, okay? So my goal, go through every Wordle word, convert those strings to the arrays of their individual characters, add those to some array that I'm building up. All right, so I want to make an array of the letters in every word. So I'll start that empty. And then I'll go through every single word in the Wordle array, the Wordle words, which is just like, take that column, iterate through it. Go through it with a for loop. So I could say for word in words.column words, or because it's the one and only column, I could just say words.column. Let me show that. What does words look like? It looks like that, right? Just column 0 is a faster way to say the same thing. So I go through every word in the words column. So that's and call each piece word, which makes sense, right? So I'm going through every word and I'm calling each word the variable name word. All right, they're all like that. So this word variable gets a chance at being cigar, gets a chance at being rebut, and so on and so forth. It's to be all those things. And for that word that I'm looking at right now, I want to split it, right? Turn it into an array of all of its characters. So it's call stir to array, one that I made on that word. And that's going to give me an array of all the characters in that word. And I want to add it to the end of this array that I'm going to keep track of every single letter in every single Wordle word. So it's like np.append, 2 letters in every word, this array that I'm getting back, and like set that back into letters in every word. Like that's the process, right? It's always np.append to this thing that you're building up, this new set of values. This time it's a bunch of things. It's multiple characters. It's always 5 characters, right? And then put it back into the array, and everybody's happy, all right? So by the time this is done, then I will have a very long array of characters here. Does that make sense? So it starts with the first characters of the first word all the way to the last characters of the last word. And there's a lot of things there. Like what's the length of letters in every word? How many letters total? It's going to be multiple 5, right? Because every Wordle word is 5 letters long. But a little over 11,000 characters, right? I've saved every character of every Wordle word in this array called letters in every word. Does that process make sense? I put them all there. And what is the last one? It ends in AVE. We can find that out, right? You can be like, remember there's an operation on tables called take, and that will give you certain rows out of it. So you can say table is name.take, and you give the index of the row that you want to take out. And so remember that there are 2,315 rows, 2,315 words then in the words table. The very last one, because the first one starts at 0, right? If there were 10 things, it would start at index 0, 1, 2, 3, all the way to 9. So it's always one less than the number of rows. So the very last index of your last row in the table is the number of rows minus 1. So if I say words.take, just give me that one at that index. Apparently the last letter in this list, the last word in this list is shave. So cool. So we got the length, we got that. And now the goal is going to be, I want to figure out how many A's were there, because like this is now I've got an array of every single character in every single Wordle word. My goal is to play the game optimally. I want a good first guess. So like I want to make a word. I can only get 5 letters, of course. I kind of want the top 5 letters, right? How many A's were there? If there were if the most populous letter in this array is A, my first guess better have an A in it. Does that kind of make sense? Like that would give me an A most often, because there would most likely be one in the word, right? So I kind of want to count like how many A's are in this array, how many B's are in this array. Like I want to count every single character in the alphabet. I want to know how many there were, because once I know that, I can just find the more popular letters, and those should turn into my guess. So let's do that. The way that you could do that is it would be a little bit of an involved process, but you could be like, all right, letters in every word, how many of them were H's? So you can check against the character H, right? And then you'd get a big long array of trues and falses, but then you can count non-zero, right? np.count non-zero, where true is 1, true is non-zero, and false is 0. So there were apparently 389 H's in all of the Wordle words. Does that make sense how I'm checking that? Versus a vowel, there were a whole lot more E's. Excuse me. Thank you. So yeah, that's how you can check that. Like, that's how many E's there were in every character. So we should make a word. Our first guess then should probably have an E in it, maybe not necessarily an H. Yeah. But we still have to find a valid guess. So we'll figure this out together. So we kind of want to do this for every character now. A, B, C, D, all the way to Z. Right? I want to do all of them. And so let's figure this out. Let's make, I want to run this process for every character in the alphabet. So I guess let's make a table of every character in the alphabet. That would work. So table of letters. Letter. So how do I make a table of letters? I can give a, I'd have to give an array, right? And make array of every character in the alphabet. A, B, C, ... But that would take me a while. I could do it slightly faster because I have a function, don't I? I could say stir to array, just like give as a single string then every character of the alphabet, because that will split it for me. That could work. That's slightly faster than typing a bunch of quotes and spaces and commas. So stir to array, that's a function that I made, right? It'll take any string and turn it into, split it up into its individual characters. So I can just do this. Why use that every character in the alphabet? Apparently. Isn't that interesting? So you could do that. Oops. And it's as if I did that big long array. Still, you typed a little bit more than you needed to, maybe. But let's call this table letters. And if I say letters, of course it doesn't show them all to me, but if you say dot show with nothing, it'll print out the whole thing. So now I've made a table of every letter in the alphabet, and I kind of want to do this process of counting each letter and turn these into numbers, right? So maybe I can turn this process into a function of counting a character's amount and then kind of apply it to this table, right? And that could work to that column of that table. That could work for me. So, yeah, that's what I want. Again, I kind of want to play this game of like, for each character in the alphabet, count how many there were. Like there are 719 L's in this letters in every word array. So let's maybe turn this into a function so that I can apply it to whatever letter we're looking at right now. So make this L a variable, right? Make this character a variable. So let's make that function. A lot of functions for examples today. Be like, all right, let's count how many times we see the character C in all the Wordle words. It's like you do this process, but it's not L or E or H that you're counting. It's whatever the character C happened to be. Yeah? And then we want to return that value. So that's me generalizing that process into a function, because now I can just call count character on like the H. That'll tell me how many H's there were. I'll count character on the E. That'll tell me how many E's there were. Yeah? So that's just me turning that into a function so that I can apply it to this table of letters, because then it'll give every one of those letters as input of that function and it will count. That's what I want, right? That's the dot apply. So let's go and look at that real quick. You have a table. If you want to apply a function, you say its name, table dot apply a function, and then you give comma separated all the different column names or indices that the function's going to need. So I've got this letters table. It just has one column called letter. I can say dot apply. I want to apply the count character function to every one of those letters. And count character just takes one thing. It takes the character itself, and that's in my letter column. So I could say letter, or I could say 0 because it's column number 0. And then I get back an array of each letter in the alphabet. It's applied it to everything. So the first one was A, right? So it applied my function to the character A, and it found all the A's in the Wordle words. How many were there? 979 A's, apparently. And then did the same for B, because B was next, right? And then applied the function to B. There were 281 B's in the Wordle word list. Does that make sense, how I did this apply? You see how it's working? It's getting to be a little bit fancy in terms of functions, but it's a good review. We're using our functions and other functions. It's great. It's great. So this is now an array of all those different letter counts. Maybe we can add it back into this table like as another column, because it has just as many things, right? It could be like letters with a column called count. Right? Count all the things. And the count column can have all these values. I can copy and paste that here. And maybe we can call this new resulting table like letters and counts. That could work. Cool, and it doesn't show them all to me, so we can do that dot show. See the whole thing. And so this is getting really close to being useful for us. Yeah, it's very useful already. Do you see, just at a glance, that E is by far the most popular letter in the Wordle words, given what we've just done? We've counted all those individual characters. Apparently, most of those words, a whole lot of them at least, have E's, potentially duplicated. We'll have to deal with that later. But have a whole lot of E's. And so like that better appear than in your first guess, because it's very likely that there's an E, and you want to know if there is one. Yeah. You also want to know if there's not one. So it's kind of useful either way. So that kind of screams we should put an E in our first guess. Does that make sense? Where I'm going with this? It also kind of screams that we should not put like a Q or a Z in our first guess, because it's so unlikely. There are only 29 words with a Q, 40 words with a Z, X as well, 37. Like, you don't want to first guess with an X in it, right? And this is telling us that. So we got all these numbers. Just to prove it to ourselves, I think we should sort, right? Let's sort this table by the count, because that would tell us like the most popular ones first, right? We have this letters and counts. We could sort, it's dot sort, right? And by default, you gotta tell it what you want to sort by. So sort by the count column. By default, it sorts ascending. Oh, J is even the worst. I didn't figure that. I didn't see that. That didn't jump out to me. Apparently, J is even worse than Q and X and Z. Crazy. So ascending is probably not what we want. We want descending. So we say descending equals true. And that gives me all these. And if you want to see the whole thing, you can say dot show. So now the J's at the bottom. But you see that the E is correctly on top, and it looks like the most popular 5 first letters, the top 5 letters in terms of how often they appear in a Wordle word, are E-A-R-O-T. And I don't think the word irrit is a word. Like you want to, if you could, right, you would want to guess a word with these 5 letters in it. I don't think there is one in the alphabet or in the language, in their little dictionary that it's checking against. That would be nice though, because that would totally be optimal. Does that make sense? Like we just figured that out. That would be optimal in what we would like. So that's cool. We can do that. What is a letter but a categorical variable? So we could turn this into a bar chart, just like visually see how popular all these letters are. That's useful as well, just at a glance, like letters and counts. Dot. Give me a bar chart where letter is the thing there. And so again, you can see relatively how popular, like there's E versus A, just as a graph. Sometimes it's better to do the sorting as well first, so I can do the same thing, like sort, and then do the bar chart instead of using the default ordering. Though dictionary order is, or alphabet order is good sometimes. H on letter. Oops. Either way, but you got, that's a useful way to make a graph. So our horizontal bar chart, that's useful. And you say what you want as your categorical variable, and everything else, it'll find the numbers associated with those rows, maybe using different colors if there were more. So yeah. Our first guess, if we can swing it, should have an E, an A, an R, an O, and a T in it. Probably not going to work out in our favor. There isn't a word with all those letters in it, sadly. But this is kind of a start, right? I hope you can see this is kind of a start. And so we could start playing around with maybe some .where conditions, because that's a good thing that we could be doing on a table. So remember that .where, you give it a column of a table, and then you say what you want done, like where all these values are above this, or below that, or equal to this. Got a bunch of different options. They're all down here, equal to, and then you can also prefix them with not equal to, not above, above or equal to, below, not below, below or equal to, all those things, between. So we want an E. Go and find all the Wordle words with E in it. So go to the words table, right? Go find every word with an E somewhere. And so that would be not between or equal to, not contained in, but containing, where all the words are containing like an E. That would work. So go in the Wordle, so words table has a words column. So go in the words table, go and look and find where all the words values are containing the E character, because that's the most popular one apparently. And this is picked out the 1,000-ish words that have an E somewhere in them. It's like these are probably, like you have to whittle it down further, of course, but these are a good starting guess, right, for your first thing. So like the next most popular word was A. So like, how do you find all the words that contain E and A? You could do this twice, right? Here are all the words that contain E. Do another where on that. So where the words column of that resulting table, those values are containing A, because A was the next most popular word letter. And so that's whittled it down more. So like here are some better options that have both an E and an A in them. Does that make sense? Because you could continue to play this game. It was E-A-R-O-T was the order of most popular letters. So it's like, all right, let's find all the words with E-A-R in them. So take all these, then do another .where there's an R. There's only 120 of those ish. So these are good guesses, right? Then an O. How many of them have an O in them too? Oops. This is getting a little long, sorry, but you gotta get the idea. Like I'm doing another .where on that with an O as well. And it looks like there's only 3 Wordle words with an E, an A, an R, and an O. Adore, a rose, and opera. And those are some decent guesses, right? What are the words that are still there? You got a P versus an R versus a D. Or no, the R's are there. You got a P versus an R. No, not an R. A P versus an S, sorry. P, S, or D. Those are the letters left out. What are the most? P was there, D was there, and S is pretty popular, but it's not the T that we really wanted, right? So maybe the one with the S, then, arose, is a decent first guess. Like it's doing as best as we kind of can. It's getting those first 4 letters that are really useful and popular, and then it's also bringing in an S, which is decently popular as well. So maybe that means that arose is a good first guess. All right. Does that make sense? That kind of analysis? That's fun. I like it. So that's one way to do this kind of thing. So let's see. So how do I want to do this? Because that's one way. We could end now and be like, that's our good first guess. But there are other ways to play this game, and I want to show them to you. So let's see. Yeah, maybe what we can do is, instead of giving up and being like, all right, we have to skip all the way to S instead of the T that we really cared about, maybe we could use these counts as like scores. And so like if you ever find an E in our letter, in our word, like it adds a score of 1233. If you ever find an A in your word, it adds a score of like 979. Like that's a way to like give a score then to every word, and then you can like sort by the score that we find. I think that would be useful. So let's try to do that. That's another way to like figure out what are the best words. So let's make an array. Like let's say we're working on a rose. We got that array. That's our like we think that that's a really good first guess. We can turn it into an array, right? Call it array or something. Our search array function does that for us that we made. And then we could like, let's give it a score based on like how popular those letters that appear in it are. So I could be like, remember that I have that letters and counts table? I can just go find where that first character is. So like, remember that the first character would be, it's my array, it's dot item 0, right? That would give me the A out of this array, because the whole array is AROSE. It's like item 0 would give me the A. I can go into the letters and counts table. I can pick out where the letter values are equal to that A character. So remember that this is like are equal to the A, that first character. And that gives me this one row, right? There's always going to give you just one row of that character and its count. And let's turn that into its count, because that could be like that's the score of that first character. So the way that you can get that out is you can say dot row, give me the 0th row. It's going to be only one and only row. 0th row is that one. And then you can go to the count, which is, this is kind of, you can treat this like an array. Yeah. And then you can say dot item 1, which is 0, 1 is the count part of it. This long drawn out process is how we can go into like the first character of this string and figure out how popular it was, how many A's were in the whole data set. And that could be used to give us a score. Like we can add up like the 979 from the A, the R contributed 899, the O was 754. Like we'll add up those counts, because those could function as a score. Like if you see an E in your word, then that's a high scoring word, right? So that could work. Let's figure that out. So let's kind of do this for the whole word then. So let's here's kind of the process. You turn your word into an array. We've already done that, I guess. And then you set like a score variable at 0, and then like every time you have a new letter, you get its score like we did here, and you can add that into the score. Score equals the score that was before plus this new value. So that's for the first letter, and you do the same thing for the second letter. That's item 1. There's always 5 letters, right? That's the score. That's the additional score from the second letter. You just keep on doing that. 3rd letter, 4th letter, 5th letter. Remember the indices start at 0, so it's off by 1 like that. And then by the time you're done, you've added them all up. That score variable holds a number that kind of decently shows you how useful that word is, right? You've added up all the counts of all the letters that make up that word. And so that's another way to get a number out of every word. And so then maybe we can turn every word in the Wordle list into this kind of number and assign a score. That could work. All right, that could totally work for us. So again, this is a process I want to do for every word, so let's turn it into a function. So you give me a word, I'll give you back a score for that word. I'll call this function get score. You give me a word. Here's the score for that word, and I need to turn that word into something called an array. So I did that here. Right? Turn that word into an array right here. And it's not a rows anymore, it's just like whatever the word was. And then everything else is the same. Like that's the new array, whatever the word was, turn it into an array of characters. Go and find the counts for all those characters and turn that into a score, and that's what we give back with a return. All right. So now I can say get score on a door, or what was it? It was a rose. And you can see at a glance, like that one was more popular than the other one that was a door, right? Because all the characters and their counts, they added up to a larger number. So like that's indicative of the idea that, okay, maybe that's a good way to order these Wordle words, and maybe we'll find one that we haven't seen before, because maybe you can't find a word with EAROT in it, but maybe you can find like a few of the high-ranking ones in weird orders that maybe are something that we didn't find doing our dot wheres a bunch of times. So like, let's turn every word into a score by applying the get score function now to every word. We can do that. Because we have this words, right? We have this words table. We now can say dot apply this get score function to each word. Apply get score to every word in the words table. It's column 0. You can say words. Or you could say column 0. That would also work. That's how you get the words out. And so let's, like this now gives me a score for every word in the words table. All right, and let's add that back into the words table. You can say words dot with a column. The score for every word is this idea. Add it back in, it's happy. Oops. And I can say words with scores equals that. And so now I've got a table that with every, attached to every word now, I've added up like how many F's were there, how many O's, C's, A's, and L's, like it was that. And you can see at a glance like which words are using more popular letters. You see that? That's quite useful. So I can sort this now. Like, all right, the one at the top should definitely be the very best Wordle guess ever, right? Dot sort by score. Again, by default, it's descending. Or sorry, by default, it's ascending. So it looks like the very worst Wordle guess you could ever have is fuzzy. All right, 1202, because it's adding up all the frequencies of all those letters. And that's apparently a horrible guess. But if you do with descending equals true, and then you get the most popular ones with our highest level, highest scores that we came up with. And you'll notice something. I don't think Erie is the best first Wordle guess. Do you? Is the best according to our scoring system? It gave us the highest score. But do you see why it's not a very good guess? Do you see why it got a high score? According to our definition of score? Yeah, just all the E's. It kept adding up the frequency of the E's. So now that's a bit of a problem, right? That's not good. The duplicates. The duplicates were an issue because we kind of triple counted the E's in that first word, and that's what gave it all of its power. It's not necessarily that every word has 3 E's in it. That's a horrible first guess. So we'll have to change the way we're looking at these scores, I think. All right. So that is quite unfortunate, right? So let's, we need a way of counting or figuring out if there are duplicates of characters, right? Because I think you could imagine that the best first Wordle guess is probably a word without any duplicate characters, right? Because usually the Wordle answer doesn't have any duplicates. So your best first guess is like the one with the highest score that doesn't have any duplicate characters. Maybe it's here already. I don't know. But no, these all have two E's in them at least. So never mind. Yeah, we need to whittle this down in a way. So we need to figure out which of these words have duplicates and we want to omit those, right? So let's figure out a good way to find whether words have duplicates. There's a few different ways to do it. Let's do it with table stuff. I think that's the easiest way to do it. So let's take eerie, for example. That's a word with duplicates. That's a word with duplicates. So we've got table. So first of all, remember that I had that stir to array function that has been working real hard for us today. I can take eerie and turn it into an array of all the characters in eerie. And I can put all those characters as rows in a table now. Be like table with a column, letter, and here's like all the letters in eerie. And I kind of want to bring together, like I want to find all the duplicates. I want to bring together all the ones that are the same. Do you remember an operation on tables that brings together all the things that are the same for aggregation purposes? Group. Yeah, group or pivot is another one, but we only have one column here, so pivot wouldn't make sense. But a group, right? If we grouped this thing by the letter called the one and only column called letter, do you see what's going to happen? Letter. Boop. I see all these. Compare what we get to, here's like, what was it, a rose? Here's a word without any duplicates. Here's a word with duplicates. How can I tell the difference? Because that's how I can whittle it down. What are the differences between those tables? What do we see? We got a bunch of counts, right? For a duplicate, we see counts bigger than 1, first of all. That's important, right? And we see counts just ones only for other letters. But we also see, because there's duplicates, we know that every Wordle word's 5 letters long. For every Wordle word that's like does not have duplicates, when we do the grouping, the counts are all 1, and so we still have all 5 rows separate. Whereas for this one, we brought together all the E's, and now the rows are, there's fewer than 5 rows. So I can say num rows, and that can tell me very quickly the difference. Does that make sense? 3 versus 5. So if it's 5, still that means there are no duplicates. Yeah. So that's a way of figuring out if there were duplicates in a word. Let's turn that process into a function. You give me a word, I'll tell you if there were duplicates or not. You'd be like, has duplicates. You give me a word, I will tell you if there are duplicates or not in it. And so this kind of process of doing this code, of running this code, kind of tells you how many unique letters there are in a word. And so it's stirred to an array of not a rows, whatever the word happened to be. So you got all those guys. And if, it's always a 5-letter word, if unique letters, so finally an if statement for the day, is equal to exactly 5, then that means that each, there was no duplication of letters. So I can say, can return true or false, or maybe yes or no. So like, are there any duplicates in this word? I'll just be like, no. The string, no. Return, no. Otherwise, if the number, like if we didn't hit here, the number of unique letters must have been smaller than 5. So else, something other than 5 must have been smaller than, for the way that we're doing things. We can say, yes, there were duplicates in this word. All right. So now this has duplicates function. You give it a word, eerie. Are there duplicates? Yes. Has duplicates, arose. Oops. No. That can be my way of filtering these scores. All right, because that's all I really need now. All right, I've got words with scores. I just want to get rid of all the ones that have duplicates. So let's apply them. the has duplicates function to the words column, because it's the words that I want to break down and figure out if there are any duplicates. And this will give me back an array of a bunch of yeses and nos. Nos if there were no duplicates, yeses if there were duplicates, and I can use a dot where if I bring this back into the table, right? So I want to say words with scores, finally. Words with scores dot apply, or no, let's add a new column with a column called are there any duplicates? Has duplicates. And the way I'm making that column is like this, just like that. And I can say words with scores. Or how about like words, scores, duplicates. Well, that's all the things that I'm having in this table. I'm adding on to this words with scores table. Now, new column of whether or not there were duplicates. Words, scores, duplicates. And so now I've got this third column with yeses and nos. Let's filter. Yeah, let's filter. Let's take what we did before, where we did the sorting for the other one. Let's sort the new table name. It's words, scores, duplicates now. But now we have knowledge of whether, right? We have knowledge of whether there were duplicates or not. So even though these are high scores, I sorted, that's still not good enough for me, right? I want dot where on this result has duplicates. It'll keep the sortedness. It'll keep whatever order you had. Has duplicates. The values there are equal to no, right? Or you can just say no by itself. Either way, right? Dot equal to is the same. And so this now, according to our scoring system, has given me some new options that maybe we wouldn't have thought about. You see, arose was the best one we came up with before. It has a decently high score, of course, according to those frequency counts. But you also see some ones above it. Later, alter, and alert. Those are all, what's the word? Anagrams of each other. Those all have the same letters. But it looks like those are better in total. Those took different combinations of letters, not just necessarily the top 3 or 4. And that gave us a better score. Funny enough. That's pretty cool. And then there's my guess. I rate. Maybe that means I should be using later, or alert, or alter, or even arose. But it's good enough. Isn't that interesting? Are there any questions about how we just came up with that? Like, this is another way of assigning a number to all these words based on frequency counts. Like, it's very cool. You could have another way of coming up with a score. This is not just your only option. There's plenty of things that you could be doing here. Technically, there are other words that are not necessarily words that you could win with, like words that are options for the day's word, that you could use to guess. There's like a bigger dictionary that may be something we could be using here against these words. So there's fancy things that you could be doing. Maybe this is not still the best thing, but it's still a good idea, right? It's still a decent analysis of all this stuff. And so, yeah, let's take all these values. Dun dun. We can do has duplicates, no. So remember that dot are equal to no is the same as just say no. Right? That's faster and smaller. You can take this. You can be like, what's the spread of all these scores? Like, are there just a bunch of really high scoring words? Are there a lot of low scoring words and like just a few high scoring words? Like, what's the distribution? You could use a histogram for that, right? Like, here's all the non-duplicate words. I guess we don't need to do any sorting. That's unnecessary. Let me keep the R equal to here, just to remind you that that's the same. Let's turn it into the without R equal to here, because that's the default. So for all the non-duplicated words, what's the histogram of their scores? And of course, you can change the bins. But this is an interesting graph because it's not immediately obvious that this was what was going to happen, right? this is an interesting histogram in that it really does look like a little curve. And it didn't have to be a curve, right? It could have been that like most of the words were low scoring, only a few were high scoring. Or yeah, it could have been like something like that. That totally could have been the case. It just so happens that the words in this list are maybe random enough. Maybe that's how we're coming up with English words. That there's like a sweet spot for the score in terms of frequency. And like there's a bunch of there's just a few low scoring words and there's just a few high scoring words according to our definition of scoring. Which is so interesting, right? That's so interesting. And it didn't have to be like this, right? But that's the distribution we found, and it's cool to be able to like explain that, right? And have that kind of analysis at our disposal, which is something we have now, right? It's a histogram of all the scores of all the words without duplicate letters. And it looks like it's just like a little bell curve there, which is nice. It didn't have to be like that. It wasn't not obvious that it would be like that. So yeah, you can do the same. You can figure out the worst words without duplicates. Be like sort by score. Here, the worst words without duplicates. Apparently, even though you have a bunch of letters and they're all different, the word jumpy is absolutely the worst. Even though it has no duplicate letters, those letters that it's made up of are just so infrequent in the answer. It's not worth your time. That's pretty cool. All right. So yeah, you got those. You could also just sort by. I think I already showed those to you. I don't remember. But you also have like, even the ones that contain duplicates are probably even worse because then you could duplicate Z's, right? That's even worse, even smaller score. So it's even though Jumpy has a bunch of different combinations, like it has no duplicate letters, it's a bad one. Fuzzy would be even worse because it has duplicates, and it's almost like, what? This is probably the only 4 words in the word list with 2 Z's anyway. So 4 out of like 2,000 chance this is one of them, so it's not useful. But we can quantify that. That's what we did. We were able to quantify, we were able to draw pictures, figure out distributions, all that fun stuff, and that's the kind of stuff that will appear on the midterm. Yeah, I'm not going to like go hardcore into like do a bunch of character-based stuff. Like that was just specific to this example, but useful still. Yeah, that was just what we needed to get the job done was all. But I think that was pretty much all that I wanted to say about these examples. As you can imagine, there's a million things that we don't have time to go over. Definitely go back to the slides, go back to the code from class. It's all there for you. Go back to the chapters. Like I'll be pulling things there potentially from there. But that was all that I could think to talk about. And that was my silly little example, or sets of examples for the day. Yeah, so that's I think that's all that I wanted to give you. I want to give you some time to study and ask questions, do what you need to do. Are there any questions for me that you would like to have preserved on the recording? All right, let me stop it.